Hey everyone. Okay, now we're going to look at another example of future value of an annuity. For this problem, we're going to be solving a very specific variable in this formula. So note that I'm using this formula for the future value of annuity. There are other variations to this, so please be comfortable using this one, or if you use other formulas, just make sure to switch the variables. Okay, let's go ahead and start. So we want to know if you can afford monthly deposits of $110 into an account that pays 3.9% interest compounded monthly, how long will it take? How long will it be until you have 6,100 to buy a boat? Okay, all right, so that's the situation here. So let's write down what is the word given. So note that this formula I'm using has these variables where F is the future value of an annuity. Annuity means you're making sequence of payments or deposits. Here, our sequence of payments is this. So that is your R value, the periodic payment. And R, little r is representing the interest rate, which is this number right here. N is the number of compounding value in a year. So here we're compounding every month. And T will be the time. That's what we're looking for, how long. So let's go ahead and write those down. So we're given in the problem our R value, the periodic deposits or payments, which is 110. Then we have the interest rate, 3.9%. In decimal, that's 0.039. Again, you simply take this value and divide it by 100. Then we have the compounding value, which is 12 months monthly. And then T, we don't know, so we're looking for it. And we're also given F, which is this number right here. So that will be our big F, that is 6,100. Okay, so let's plug in all of that into this formula and try to isolate T. So let me go ahead and do that. So we have our future value, which is 6,100, is equal to R, that's 110, times parentheses 1 plus the rate, that's 0.039, divide that by 12 to the power of 12t minus 1, close the parentheses, over R over N, that's 0.039, divide that by 12. Now, if you want, you can calculate that on the side. So the R over N value, that is your 0.039, divide that by 12, which will give you a 0.00325. So just pull up a calculator and do these calculations. I'm going to go ahead and replace that right here. That way our formula doesn't look so crazy. So this is 0.00325. So here as well, 0.00325. Okay, so we are looking for T. T is right here on the exponent, so let's start isolating. So first thing you want to do is multiple ways to do it, but I'm going to go ahead and get rid of this denominator. So I multiply both sides by that. So you will have 6,100 times 0.00325 is equal to, now when you multiply that on the right-hand side, it will cancel. So you simply have 110 times. Now here, I'm also going to go ahead and add these numbers. So that gives me 1.00325 to the power of 12t and then minus 1. Then I close the parentheses. Okay, so now on the left-hand side, if you put this in your calculator, I have about 19.825 is equal to, so I have 110 times 1.00325 to the power of 12t minus 1. Now again, we're still trying to isolate t, so I need to get rid of the next component, which is this 110. I'm going to go ahead and divide both sides by 110. So now if you do that, this will cancel out. On the left-hand side, you're going to get 0.18022. Again, try to write as many decimals as you can. I'm going to stop right there, and so that you have good accuracy at the end. So now that leaves me with, on the right-hand side, 1.00325 to the power of 12t minus 1. Okay, now again, I'm looking for value of t. So now the next thing I need to get rid of is this. So I'm going to go ahead and add 1 to both sides. If I add 1 to both sides, I'm going to get 1.1802227 is equal to 1.00325 to the power of 12t. All right, so the next thing we're going to do is take logarithm because the variable we're solving for is on the exponent. In order for you to bring this forward, you need to take logarithm. So we're going to go ahead and apply log on both sides. So on the left side, you have log of 1.1822727. And on the right side, again, we're taking log of 1.00325 to the power of 12t. Now that we have logarithm, it allows us to bring down the exponents by the properties of logarithms. So you have now 12t times log of 1.00325. And on the left side, you can just rewrite or put that in your calculator. You get a decimal. This will give you about, so if you insert this in your calculator, you will have 0.07196 5646. I believe that's the decimal you'll get. Now, again, we're looking for t, almost there. T is right there. T is multiplying 12 and log of this number. Again, put that in your calculator if you want. So I need to isolate t. I'm going to go ahead and divide by 12 log of 1.00325 on both sides. So this is 12 log of 1.00325. And now finally, all of this cancels out. T is isolated, so let's write T is equal to all of this. Now you can put all of that in your calculator or do one at a time. So I have 0.071965646. And then when I put this value in my calculator, I get 0.016910002. All right, now you put those in your calculator, you'll have about, this comes out to 4.25579. Now this is in years, so just keep that in mind. This will be the value in years. Now, if you want to use different units, for instance, let's say you want number of months. So we know there are 12 months in a year. So if you want it in a different unit, so let's say if you want the value in number of months, we simply take our t value and multiply it by 12. So you have 4.25579. You times that by 12, you'll have about 51.06 months. Now, since it's a little bit more than 51, I'm going to say approximately 52 months. And this is extra. You don't have to do it if you don't want to. But if you want to keep your answer in terms of years, that'll be the value. Or you can approximate that to be 5 years if you want to approximate. Or if you want it in months, we can always do that. And if you want it in weeks, you can also multiply by its converting factor. Okay, I hope this makes sense. I'll see you next time.